Hey guys, Carlos here. While making games with Unity, you will find the need to send and request data from a remote server. One of the most common ways is by using a RESTful API, and this is nothing else than code that allows two software programs to communicate with each other. With RESTful, we can get, put, post, and delete data types. To communicate, your game and the server will need to use a common language. That's JSON. JSON is a lightweight format for storing and transporting data. It's also self-describing and easy to understand. For all this, there is an API available in Unity. That's the UnityWebRequest. So let's try to use it. The first step will be to get a JSON from any web server. For this video, I will be using a free public API website. Feel free to use your own and just replace the URL in the following example. As long as you get a JSON response, you are good to go. Let's open the Unity editor and create a script to write our first GET request. The name of the class is irrelevant. I will call mine test controller. Remove any unused assemblies from our class. You can do this by clicking on the light bulb and selecting the option Remove Unnecessary Usings, or with the shortcut Ctrl-RG, and create a method called testGet. Again, the name could be anything. Now we declare a URL variable and assign an empty string for now. We will inject later the actual URL of the web API of our choice. Here's a tip. Declare variables by using the var data type. The compiler will resolve the type when a value is assigned. In this case, an empty string will make this a variable of type string. Next, we will use the UnityWebRequest API for the first time. As you can see, the compiler will not recognize UnityWebRequest until we add the respective assembly at the top of the class. To do that, we can use the label menu and select using Unity Engine.networking. The shortcut to bring up the label menu is Alt-Enter, at least in Windows. This line of code will instantiate a GET web request. It will be stored in the "w" variable. Next, we set a content type for the request, letting Unity know we are dealing with a JSON response type. We are now ready to send the request. We simply call send web request on the instance we call www and grab the resulting operation in a variable we can call operation. And I will explain why. We are sending the request to the server, but we will not get a response back immediately due to network latency. Therefore, we need a way to wait until the response makes it back to Unity and then process it. Fortunately, the variable operation exposes a property called isDone, which will tell us when the operation made it back with a response. Now we just need a way to wait for that. This is where the async magic comes into play. The logic in this block says, wait until the operation is done. But as you can see, the compiler does not immediately recognize task or the word await. For task, we just need the correct assembly added at the top. The await keyword provides a non-blocking way to start a task. Then continue execution when the task completes. Our method just needs the async modifier added to its signature. That signals to the compiler that this method contains an await statement, that it has asynchronous operations. Okay, that was the most challenging part of the code. We are ready to process the response. For now, we can simply mark it as success or failure. If success, the console will print the JSON response. Otherwise, an error will be output instead. To quickly call this method for testing, we will mark it as a context menu. One last important detail. We need to inject a proper URL that returns a JSON object. I will use this free and public API. Feel free to use what you prefer instead. If I test mine in the browser, I can see the JSON object return. That's it. Let's make sure our code compiles in Unity first. Create an empty game object in the scene and attach the test controller script to it. In the inspector, click on the button with the 3 dots. That will bring up the options submenu for our test controller component. You will find our testGet submenu item at the very bottom, which was generated for us by adding the context menu attribute on our method. Go ahead and click it and check out the console. Nice, success. Now click on that log and see the resulting JSON printed. Just the same JSON we got back in the browser. Okay, cool, that's awesome. At the moment, we are only retrieving the JSON as a string. But to use its content in our code, we have to deserialize it first. Let's modify our code slightly and introduce a try-catch block. The purpose of a try-catch block is to catch and handle an exception generated by our working code. The try block contains the guarded code that may cause an exception, in our case, the JSON deserialization step. There are many JSON libraries out there. I will use one of the most common, JSON. More specifically, a version that fully supports all Unity platforms. I'll leave the link to the GitHub repo in the description. The install process is very straightforward by using its package installer. Feel free to use other installation option or simply use a different JSON library. We will make sure that our code is very flexible to adapt. Once sub.json is installed, we can add the respective assembly. Now we need to map the JSON response to a class. This class will need property names matching those within the JSON object. Once done, we just let the JSON library know which type of object will be deserializing. Okay, time to test our code. We are going to use Visual Studio's debugger so we can inspect the resulting instance of the class user. We could continue to use debug log, but the debugger is way more convenient by far. To do this, go to Visual Studio and click the Attach to Unity button at the top. For this to work, Unity must be open. Visual Studio will build your solution and then enter into debug mode. The bottom bar of the window will become orange. Let's place a breakpoint at the line by clicking left of the line number. Go back to Unity and execute our code by using the context menu once again. Visual Studio will stop execution once the program reaches that line of code. And now we can inspect the state of our code in real time. Let's step over to the following line so the object is deserialized. You can step over by clicking on the step over button, or you can use the keyboard shortcut F10. If you hover over the result variable, the debugger will show you its contents. We got all the correct data deserialized. Another option is to open the locals window. The locals window will show all available instances up to this point of the execution. Up to this point, all the code is inside our test controller. Let's first encapsulate this into its own class. Let's call it Happy HTTP Client. Trust me, you will be happy to reuse this code on and on. This class does not inherit from a behavior. This will make it possible to instantiate it from anywhere. The first step is to copy and paste our code into a new method named get. The difference is that the URL will be passed from outside as a parameter. Make sure to add all the necessary assemblies at the top of the class. Now let's get back to test controller and refactor it. First, we need to create an instance of the Happy HTTP client. And now we can call get on that instance and pass the URL. We will get the response back, and that's it for now. Let's give it a quick test. Yep, same result. But something is odd here. Our Happy HTTP client class should not know the user class. Let's remove that dependency by using generics. Don't worry. I know generics might sound a bit difficult to understand at first, but trust me, it will make your code more flexible. Let's replace the user reference with tResult type as the return type, and also requires to pass its signature. The name tResult type is irrelevant, and you can name your generic variable as you wish. I prefer to choose a self-explanatory name. Two more things. Updates reference in the JSON convert step and return default instead of null, as the compiler has no guarantee this is a nullable type yet. Brilliant, it compiles. Let's get back to test controller and let our get method know the result type, user. Time to test it. Excellent, still the same result. We still have a problem. There is a direct reference to the JSON serialization library. Our HTTP client should not know how we are deserializing the response. We can see the namespace at the top. We need to move that implementation concern out of there. We can do so with an interface and the strategy pattern. I'll explain how. An interface name will start by the leading I letter, followed by the actual name of the interface. In our case, iSerialization option. In the declaration, you just need the interface keyword instead of class. Using interfaces is an excellent way of keeping our code decoupled. An interface is nothing more than a contract between an object and its user, a contract with an agreed collection of method and property declarations. In our contract, we will declare a deserialize method that receives an argument of type string. Also, the T at the beginning means that we will return an object of type T, that is generics again. We will tell the compiler that we don't know that type yet. The second T is to enforce the caller to let the method know which type it needs to return. It will be more clear when we use it. Now let's make an implementation of this. We can call it JSON serialization option. This class will implement iSerialization option. Immediately, the compiler raises an error, warning that we are not complying with the contract. We need to implement the deserialize method and match its signature. Cool, the error is gone. Let's copy and paste the serialization code into here. Now let's resolve the missing reference to need-to-insolve.json. We can replace tResult type with T and use the local variable text instead of JSON response. Also the missing reference to the system assembly. Cool, that looks better. And remove unused assemblies. Back to happy HTTP client. Let's add a constructor so we can inject the interface. We will store its value in a private read-only field. You can let Visual Studio add it for you. And this is just me preferring underscore for private field names. Cool, now we can use it. But before that, let's wrap the async code within a try-catch. A handle exception inside an async method could be swallowed and die silently, which would end up in your program not behaving as expected. Okay, now we can remove deserialization responsibility by using the interface. See how we let know the deserialize method that we will be dealing with a response of type tResult type, which is also generic, but it will be passed by the caller of the get method. A bit of cleanup in the exception log. And now we can safely remove the dependency to the need-to-insolve.json namespace at the top. One more thing. We can move the content type string to the iSerialization option. The string is directly related to the serialization strategy that we choose. So let's add a read-only property of type string to our contract. The compiler raises the error of the missing property. Let's add it and just set its value. Back to the get method, we can now use the interface to set the content type of the request. Let's clean it up a bit. We don't need to keep a reference to the JSON string. Instead, we just pass it directly to the Deserialize method. Okay, we are done in this class. Back to test controller. We have an error telling us that we are not passing a serialization option in the constructor. So let's create it and pass it. That's it. Let's test it. Same result. Great, we made it. You can continue improving the HTTP client class by adding a post method. With post, you will need more settings like authentication, headers, etc. For that, you can continue to use the strategy pattern. Leave a comment and let me know what you come up with. Good luck! If you like this video, please subscribe to my channel. Also, let me know which topic you would like me to cover in the next video. This was Carlos. Thanks for watching.